This final video on fractions takes the rules that we're talking about using for our different arithmetic operations with fractional numbers and applies those same ideas to algebraic expressions. Remember that the algebra rules that we use always come from arithmetic rules. So if you're in doubt about how to what rules you're allowed to use in algebra, you should ask me, ask Ashley. One of us will explain how those are coming from the regular rules for arithmetic that we've already talked about. So in the first problem, we're subtracting fractions. So if you think back, when we did subtraction with arithmetic, we found a common denominator, and then we were able just to do the subtraction across the numerators. Here, I have a denominator of 4 and a denominator of 3, and so we need a common multiple of 4 and 3, and so the product 4 times 3 will always work, and in fact that's the smallest denominator that we could use. So 12 would be a multiple of 4 and also a multiple of 3. So we're going to rewrite each of these fractions so that the denominator is 12. To accomplish that with the first fraction, I need to multiply the top and bottom by 3. Remember, well, I didn't mean to write it like that. Remember that we talked about if you change a fraction by multiplying the top and bottom by the same number, then the value of the fraction didn't change. So 3 times x over 3 times 4 is going to be the same fractional value as x over 4, but now the denominator will be 12. So I can play the same game with the other fraction. To make that denominator 12, I need to multiply the top and the bottom by 4. Now we need to be careful here because I need to multiply the entire numerator by 4. And so to denote multiplying the entire numerator by 4, I'm going to put that original numerator in parentheses. That's all bound together. That's the numerator. When we write a fraction like this, we don't normally put the parentheses around the top because the fraction bar essentially accomplishes that, right? The fraction bar tells us that all of this is in the numerator. And so we know that by just putting the fraction bar from one end to the other, that is grouping this stuff together. But when I need to multiply by 4, I need to explicitly put the parentheses on there so I remember that the 4 is being multiplied by this entire thing. So the first of these fractions is just 3x over 12. The second one, well, it's also over 12, but in the numerator I have a little bit more work to do. I need to use the distributive property. I need to multiply this 4 across these parentheses. So I need to do 4 times 2x and 4 times this positive 1. So 4 times 2x is 8x, 4 times 1 is 4, and I would have this. Now I'm still not done. I have to do the subtraction just to the numerator, right? We got the common denominator so that we can just do the operation to the numerator. And I have the same issue again here. The fraction bar here is what's binding all of this together. So the fraction bar is telling us that all of this is together in the numerator of this fraction. When I combine these, I need to use parentheses to accomplish that same thing. The fraction bar no longer conveys that to me because it now goes far beyond 8x plus 4. So I need to put parentheses in to remind myself that all of that is being subtracted. So I'm going to distribute this minus sign through the parentheses. So I'll have minus 8x and minus 4. 3x minus 8x is minus 5x minus 4 over 12. So that was a lot harder than the problems that we did with just numbers and arithmetic. But notice that there were no rules that I used that were different. The only thing I have to be careful of here is when I have a complicated expression in a numerator or denominator, when that expression moves around, I better carry parentheses with it to make sure that it stays bound together. I'm going to erase this one, so if you need to pause and make a note, do that, but I'm going to give myself some room here. All right, you'll be glad to know that no other problem here is anywhere near that bad. Addition also requires us to have a common denominator, but in this case, the denominator is pretty simple. I have a 2 here and an x here, and so a common multiple of 2 and x is just 2 times x. To make the first fraction have 2 times x in the denominator, I'm going to multiply the top and the bottom by x. That rule about having a common multiple in the top and bottom giving us equivalent fractions is not just limited to arithmetic. It works with algebra as well. So multiplying the top and bottom by x will give me a fraction with the same value. For the second fraction, to get the denominator to be 2 times x, I need to multiply the top and bottom by 2. So multiplying 1 over x and top and bottom by 2 is going to give me an equivalent fraction. And now both fractions have the same denominator. And so now I can use that denominator and do my operation just in the numerator. X times x, we would normally write that as x squared, but it's not wrong to write it as x times x. And 2 times 1 is 2. So that's the fraction that we get when we add x over 2 plus 1 over x. For multiplication, we know the rule is just multiply the numerators and multiply the denominators. Notice how suddenly I'm using parentheses when I'm combining these things just to make sure it's clear that the whole things go together. So x plus 1 is one object, x is another object. So I'm putting parentheses on when I'm losing my fraction bars just to make sure I'm keeping things grouped correctly. What we did with numbers at this point is rather than multiply things out, we looked to see if there were common things to cancel. And in this case, there is. In the numerator, there's a times x. In the denominator, there's a times x. We have 3 times x here, 3 times x times 2, and here we have this stuff times x. So because that's times x and times x, I can cancel those out. Notice that I would not have been able to cancel this other x with anything because it sits here without being x times anything, right? It's not x times 1, it's x plus 1. So remember, I can only cancel out a common factor, a common thing that's multiplied in numerator and denominator. So that is the only thing I can do. There's no other factors at all. The numerator is x plus 1. There's nothing else I can pull out of that as multiplication. The denominator is 3 times 2. And so my final result is x plus 1 over 6. For number 4, this is not much different. We know that if we have a division problem, we turn that into a multiplication problem where instead of dividing by x over 3, we multiply by the reciprocal, 3 over x. So remember, the reciprocal is just flipping the fraction over. So this will be the product of the numerators. And notice that because my fraction bars are not grouping things together for me anymore, I'm going to use parentheses to keep things grouped over 6 over x. And in fact, I'll go ahead and modify that just like I did before with numbers. I can see that there's a multiplied 3 in the numerator, and so I'm going to go ahead and write, instead of 6, I'm going to write 3 times 2. So I've used 3 times 2 instead of 6 because I can see the 3 in the numerator just begging to be canceled. So in the numerator, that is a times 3. In the denominator, that's a 3 times. So those are multiplied in each case, so those are allowed to be canceled in our fraction. And that's the only thing that does. Notice this 2 is multiplied by x, but it's not 2 times the entire rest of the numerator. That's what it would have to be. It would have to be a factor of the entire numerator. So I don't have 2 times everything else in the numerator, and so I can't cancel that 2 with this 2. Same thing with this x. This x is not x times everything in the numerator, everything else in the numerator. It's only multiplied by the 2, not the other stuff. So because of that, x is not a factor of the top. It's just a part of the top. And I can't cancel anything unless it's a factor of the numerator and a factor of the denominator. In other words, it's multiplied by all the other stuff that's up there. So that is all that will cancel in this problem. So I'll have 2x minus 1 left in the numerator, and I'll have 2 times x in the denominator. And nothing else will cancel, even though this is very tempting to look at, but I don't have 2x times the rest of anything up here. So because that 2x is not times anything, I can't cancel it with a 2x down here.